All right, so now let's move on to limits with infinity. So if we're taking limit as x goes towards infinity, infinity is not a number. You want to think of x getting really large, positive, or if we're taking the limit towards negative infinity, really large, negative. All right, so just thinking of the graphs. So you know what f of x equal x cubed looks like. So as x's are moving out to the infinity, the y values are going here. So this does give us infinity. And so this gives you the idea, not that we're going to ever write this, but infinity cubed is infinity. So just be thinking that, right? That I can take infinity and cube it. So here, if I look at the graph of e to the x, moving on out to infinity, the y values are going up, so it is infinity. So that gives us the idea that e to the infinity is infinity. Again, you're never going to write this. I'm just giving you these little thought bubbles to think about. Root x looks like this. As x's go to infinity, the y values continue to rise, so it is going to infinity. So again, more things to think about. The square root of infinity is infinity. Again, we're never going to write that, but you're thinking. Okay, so this is a sine of x, and you know what sine of x looks like? Like this. As x's are moving towards infinity, the y values are going towards, they're not going towards any one y value. They keep oscillating between 1 and negative 1. So limit means as the x's are approaching infinity, what are the y values are approaching? They're not. And when they're not approaching any one number, we say does not exist. All right, so thinking about the graph of ln of x, as x's go to infinity, the y values continue to rise. So that's going to infinity. E to the negative x, is this graph. So as x's are moving towards infinity, I can see that the y values are going towards 0. So let's think about what that looks like. Thinking e to the negative infinity is like saying 1 over e to the infinity, and that's 0. Again, just thinking all these things. You're not ever going to write this kind of things down. So if I have r rational number, and it's got to be positive, like 2/3 or 3/2, it's in the denominator, right? If I have the x's in the denominator to this positive exponent, then I will have 0 as a result, whether it's positive or negative infinity. Okay, so this is important. Before we had 0 over 0 as more work. I'm adding to that. Now we have infinity over infinity and infinity minus infinity. So these are all called indeterminate forms, and all three of them mean more work. So just get used to these three things. 0 over 0, infinity over infinity, infinity minus infinity. Okay, so if I was to put it in infinities here, I'd have infinity minus infinity plus 2, infinity plus infinity minus 1, all over infinities. Okay, so what I'd like you to do is to think about the highest powers. When we're going towards infinity or negative infinity, the highest powers rule. So I'm going to say this is approximately equal to, and I put approximately because I am just taking the highest powered terms and all of their coefficients. So here I can cancel the x squareds, and this just gives me 4/3. That's the limit. So limits as x goes to infinity, use the highest powers rule. All right, here we go. Let's do this one. Limit as x goes to infinity. It's approximately, yes, I should have put a little approximately equal to x to the 5th over 2x squared. Carry the limit along, cancel, so I get x cubed over 2. So now evaluated infinity. Infinity cubed is infinity, divided by 2 is still infinity. It's infinity. Here I'm taking the limit as x goes towards negative infinity. Carrying that along, so I have 3x over 5x squared, cancel. So I get 3 over 5x, let x go to infinity. I get an infinity in the denominator, 3 over infinity, that gives me 0.